Good evening, everyone. A very warm welcome to all of you joining us for another exciting chapter of Wisdom Waves 1.0, organized by the IEEE WIE Affinity Group of the University of Ruhuna. Today, we are diving deep into one of the most crucial topics in the software engineering world, the journey from code to production. We'll explore the full process behind it, from version control and build pipelines to containerization with Docker, deployment environments, and the CI/CD workflows that power modern software delivery. And we'll also touch on how monitoring and post-deployment practices help maintain the quality and reliability of production systems. To guide us on this journey, we are honored to have two of our amazing speakers with us today, experts who have hands-on experience in taking software from development to deployment. Our speakers are Mr. Chandla Jayathilaka, a final year computer engineering undergraduate, former developer, engineering intern at LSEG, and joining him, we have Ms. Samyukta Vimalanathan, a final year computer engineering undergraduate, former software engineering intern at Sin7. We are truly excited to have them both with us to share their knowledge and their industry insights. So please put your hands together and over to you, Ms. Samyukta. Yes, Miss.
Yeah.
I hope the screen
Good
is
evening,
visible.
everyone. Yeah.
Samyukta, your voice is a
Yeah.
bit low.
Now, okay. Is it audible now? Little bit.
Is
Still
it
having
low
issue?
as I hear it?
Still having issues?
Can others hear? Then it's okay.
Yes, we can hear well.
Okay.
Sorry, slide.
Okay, fine. Good evening, everyone. I'm really excited to take you all walk through this topic today that every software engineer must know. How your code actually moves from your laptop to the real world. Many of you have already built an app, React app, Spring Boot APIs, .NET APIs, Python apps, and they have working in perfectly in your machine. But real world is different. Client, companies, and users need all your app to be running globally, not locally, right? So real goal is to deploy your apps in that all of them can access through simple link, simply URL, right? This journey is bridge between it works from my machine to it works for everyone everywhere. So today, in next couple of hours, we will be discussing about why deployment needed, what Git is, what automated build is, what CI/CD means, and Docker containerization. Now we will move to next slide.
So there's an issue with the slide. Give me a second.
Let's move to the pipeline slide, Chandula.
Ah.
So now let's look at the most important part of modern software development, code to production pipeline. This pipeline represents the complete journey of code takes place before it comes to a live application. I will talk about through this each and every step one by one. First one is code. This is where everything begins. Developers write the code and in their laptops and test it locally and push it to shared repository like GitHub, GitLab, or Bitbucket. Purpose of this step is collaboration. Everyone's code come to a central point, a central place. It means, but just pushing your code doesn't mean that your code is ready for the user, right? That's where the steps pipeline begins. And second step is build. After the code is committed, an automated server takes over, CI server. So, system performs steps like compiling the code, installing the dependencies, running initial unit tests, and so on. These steps make sure the code is buildable, which is having no any dependency issues or some, but to move forward. And third step is test. In this step, code is deployed to staging test environment. So QA team will perform the deeper testing, include testings like functional testing, integration testing, regression testing, API testing, and UI testing. In this stage, this ensures the application behave correctly, and main thing of this stage is new code, new changes that we make doesn't break the old features. And next stage is release. Once all the test cases are passed, the build will marked as stable. And this step will prepare the code for packaged for the deployment. In many teams, this is the point where approval happens. Team leader, DevOps person will review and approve the release. Now, Sophia becomes an official version to ready to be deployed. Final stage is deploy. This is the stable build. This is the stage where the stable build is pushed to the production servers, the environment where real users can access your application. So this entire pipeline ensures that the software moves from deployment to development to production in a safer, consistent, and automated way. Now, let's look at the version control. Version control. I think you might have heard about version control earlier also in your modules. Why we use that? Tracking the changes. You know the basic, right? Uh, these are the tracking the changes, enabling collaboration. These are some points in that. I guess I hope you all know some good things, and let me move to the code part, implementation part, where we can do a demonstration. You can see my screen here. I have just cloned a repo in my thing that you have to work on a repo. Thing that nowadays you are following software architecture projects. For that, you need collaborations and you have to collaborate and work on it. So for that, what you have to do is from main, I have cloned this repo. And here you can check in which your branch is now. I can't even shift it to main. Now it is shifted to main. If you want to work if you want to think like these are the features already developed there. If you want to build a new feature, think like you have to add the login feature or what kind of any feature. So when you are adding that, what you have to do is you have to create a branch for it. and which means you are not destroying the main code. So when you are creating a new branch and working on that one, it means that you are taking a copy of that branch and you are working on that branch. If you make any change and then if you made a pull request, uh, the main team lead or someone, they will review your code, and if that code is okay and everything, there is no any conflict, he will merge that to the main. So that's how the practice is. So now we will go through this one. Now what I'm going to do is I will show you creating a branch and making up to PR, making PR request. So here we can create a branch. Just I'm naming like feature testing, feature testing 0001. uh, some companies follow some good practices. Normally, we would like feature slash, what's the POR or something, what's the code, there will be something code or something. Sometimes, in some companies, you can not even, you no need to push it to main, therefore, some, but you can push it. Uh, Now I have developed a branch and I have created a branch for testing. Now you all can view that I have switched to feature branch. So here I'm not making much changes. I'm just gonna have a comment. I'm going to add a comment. So I'm here adding a comment. Add number specified. So what I have done is the code space was already there. Now I have made a change. So when you are doing, you have to, when you are developing features, that's how you have to do. So I have made the change now. So when you go to here, you could able to view the change here. So now changes are staged, and you have to create an appropriate suitable commit message. Here it's not a feature, but I'm just putting as feature and add added like added. Mhm. Related to number specific validation. So I have added added a commit message. Every time when you push a code, add a commit message which is relevant to them. So everyone collaborating there can understand your message. And I'm going to publish my branch that I have created locally. So we can able to view here. Here, here it is showing here in the GitHub, my testing branch has been created 11 seconds ago. And you can able to see here. Now we will make the pull request. I'm adding a description like testing. Here, this is how you will create a pull request. Now, you can view here, you have I have made pull request here. If the and pull request is no any conflicts are there. If there is any conflict, what you have to do is you have to resolve and you have to make a pull request. This is how the implementation. Hope you have got it. Now, Chandala will be continuing from this part. Uh, Chandala.
All right, I think the screen is visible. It's visible, right?
Yes. Yeah, it can be seen.
So first we'll go for a quiz. Can you all go to this quiz in Mentimeter? Mm. Can you guys join quickly? There are 8 up to now. Mm. Okay, I think we start. So this is MCQ quiz with a 15-second time limit. Uh, Actually, I haven't put any multiple answer. There's only one answer. Uh, in this quiz, there's only one answer. So you have to answer as fast as you can. And uh, at last of the session, we'll see who's the winner is. Okay. 5 are ready. We will have in total 13 questions. So we'll go through the quiz during the session one by one. I'll start in about half a minute. We'll start now. Uh, According to the pipeline, what is the third step which comes after the build? When you answer quickly, you will score more points. Two had answered incorrectly, code and deploy. Three are correct, so the majority is correct. We'll go to the next question. What does branching in Git allow developers to do safely? Okay, near majority is correct. Right, we'll move on to our slide and then let's come back here. Okay. Next, we'll talk about deployment environments. Mm. Okay. Firstly, you never want to make any changes in the live website, but the live website means what is in production. That means what the end users can see, what the world can see. That is your live website. For example, we'll take this as a website. So in here, if you do changes to that website directly, can you imagine that if there were any issues with your changes, like if there were bugs or if the things you did uh, had somehow resulted in a broken application, then it would affect the entire uh, global set of users who will be using that application. So imagine Facebook did this. If Facebook had done a thing like this, then all the people who will be using Facebook will be unable to use that application. So that's why we have different environments in which we deploy our applications. First, you have the development environment, which we call as dev. This is your local machine. So that is your laptop. In here, it is like your private sandbox. You can do anything you like, and you can write your first draft, try new ideas, and make a mess. No one sees it. You can always correct your code, and when you think now your code is okay, you have tested, and it is working fine, then you can move on to the staging or QA environment. In there, that is a mirror of the production environment. This is like, if we think this is like a big research paper, the development environment is like what you're writing in the research paper. Then in the staging environment, you give the research paper for one of your friends to proofread, so that when he sees the research paper, he can see whether there are any issues what you have written, then he can suggest any changes. Like that, in our staging environment, we can catch the bugs before it is actually implemented. So, if we are satisfied with our staging environment and the application is working fine, then only we will go to the production environment. That is the live server. In here, all the global users will be able to access the application. So, I think most of you had seen this meme on the right side. Test in production, what could go wrong? If you test in production, everything could go wrong. That's why we have these kind of environments: development, staging, and production. Next, we move on to the automated build. So, how do we get our code from dev to staging in a safe and a repeatable manner? Because nowadays, software development is working as cycles. You push one code and then you wait, uh, and then you develop it much more and you have update. Then you push that update. So every time you have to go from dev to stage to product. So to go between this environment in a safe and a repeatable manner, we can't just drag and drop our files. We need an automated system for that. So in that, uh, for that, we have the CI, continuous integration. As soon as the developer commit the code, then uh, this pipeline gets activated. This pipeline is activated by build server. The build server, that is either Jenkins or GitLab CI or GitHub Actions. From those tools, we are able to activate this pipeline. It's like a robot who will do these things for us. So what it does is, when the developer pushes his code, the build server pulls the new code from the version control, whether it be GitHub or GitLab. It will pull the new code and then it compiles this code into an application. Because as you all know, we can't just run a code. We have to compile it. Compile the program, then only we can run as an application. So that is done by the build server. Then it will run any tests that are written in the code to check for any immediate bugs that it can catch. If there are no bugs and it is okay, the test are passed, then it can package this resulting application into an artifact. This final result we call as an artifact. Okay. So this is that same thing in a diagram. The code, when committed, it goes and the CI pipeline builds it, runs the tests, and then packages it to an artifact. Next, we have the CI/CD. CI/CD means this is the previous image I have cropped this part, the CI part. This is the full image. In here, you can see this is a CI/CD pipeline. You must have heard this CI/CD term. CI/CD means continuous integration and continuous deployment. In here, this is, if we zoom out to see the full picture, this is the infinite loop of modern DevOps. It's a fully automated process that connect all the steps we had learned earlier. Now we already know what is CI. that is automatically building and testing the code whenever the developer commits. So in CD, actually there are two. One is continuous delivery and the other one is continuous deployment. So what is continuous delivery? That means it automatically prepares the release and uh, it waits for a human to give the final go signal. That means it is having the code in a staging environment, not in the prod. In the final staging environment, and it is 100% okay, but it still waits for a human to authorize the deployment to the production. That we call as continuous delivery. In continuous deployment, it is fully automatic. If the code passes all the tests and all the staging tests, then the pipeline automatically deploys it all the way to the production. Here, no human authorization is needed. So that's the difference between continuous delivery and continuous deployment. This is the entire pipeline, CI/CD pipeline, the main thing we are talking about in DevOps. Because of this automated system, Amazon, Netflix, and other companies are able to deploy hundreds of updates to millions of users within a short period of time. Next, we'll move on to a demonstration. So I'll yeah. This is Jenkins. I hope you know what is Jenkins. In this one, I have posted this in EC2, and from the EC2, there's the port 8080 it is running. There's issue with internet, I think. Okay, I'll first go to this. So this part I have created to demonstrate the Jenkins CI/CD part. This is a Jenkins file. This is the code in which the pipeline is defined. This is a pipeline. Here, agent any means we can run this in any available agent. That means Jenkins agent. Then we define the environment variables, and then these are the stages. For each pipeline, there are stages. From one to one, we go from one stage to another. So these are those stages. First, we'll check out the code. This is a sample pipeline. Then we set up the environment. This is the application what I have created for this sample demonstration. For this application, it will first check out the code from my GitHub repository, then set up the environment, then install the dependencies, then run any code linking, run the test, and then have that artifact archive. Then we'll move on to building the Docker images because we need Docker files that is better when running application when in production. We normally use Docker images to deploy our applications. Then we'll test the image, then push to a registry like Docker Hub, and from that we'll get it again and deploy in our server. So this is deploying staging and then deploying production. This is a sample pipeline. Let's see how this works. So this is the Jenkins. We can run a new pipeline by selecting new item. Mm, I think there's showing the internet. Uh, you can add a name, sample pipeline with the pipeline and then okay. In here, we can also add our Jenkins, that Jenkins file I showed earlier. We can add this entire pipeline here also. If not, we can get it from our source control. When we select pipeline script from SCM, then we can add Git and have the repository URL in here. So this is my GitHub repository. Here I can give the URL from here. Then add it here. Next, this is a public repository, so I don't need any credentials. And the branch is main. Next, I had to give the script path because I had created this inside a folder. I this pipeline will not find the Jenkins file directly. So I should say that this is inside this Jenkins demo folder. Like this, I can add the script path. Next, yeah, that's all. We can save this pipeline. So it will get the entire pipeline from this uh, my repo. So whenever I need to change the pipeline, I have that Git history too. So I can roll back if I needed to go to earlier version. Mm, Here we are in the sample pipeline. I can run do it. It's taking time because there's a lag in the network, which is hosted in an EC zone. Mm, This is the build it had done. Here you can see the pipeline overview and console output. I show the pipeline overview. Here, this is the pipeline. What I have coded is shown visually here. Check out the SCM, then set up the environment, install dependencies in the code, run the test, build the Docker image, test the image, then push to registry. These parts in the code I have not implemented. I have just added the stages. That's why there you can't see this tick mark. So this is the full pipeline which I run. If there were errors, then you will see a crossing here and you can troubleshoot what had happened. So this is how you will run a pipeline. Yeah, that's CI/CD both. Deployment part is also there, but for this demonstration, I have only included the stage names. Okay, we'll move on to that presentation. Yeah, we have another quiz. Can you guys enter the quiz again? Uh, you can't see the QR here. No. Come on, quickly. When you join, don't leave the quiz because I think your score will not be saved if you leave. Mm, okay, I started because it's running out of time. I start the quiz. Which deployment environment is described as a mirror of production? Mm. Yeah, most are correct. Let's move on to the next one. In an automated CI build, what is the final package result? Yeah, one had got that wrong. That's the artifact. Then move to next one. Which environment is called the final boss that your users see and interact? Okay, that's the production. The dev environment is the first one, but we are firstly developing the code. Production is the final environment we'll be deploying our application. What does CI in CI/CD stand for? CI means continuous integration. Remember that. Okay. Last question for this part. Which process automatically deploys code to production without human? That also most had got correct. But, we'll move on to more slides again. Yeah, Samyukta, you can continue.
So guys, back to the session. So now we will see a common problem that every software undergraduates face. Okay. So I may tell you an instance where you would have remember somewhat like you would have faced like that. When I was in the third year, for like I also faced that kind of scenario. So the scenario is when you are building something, when you want to do some React app or any kind of application, what you will do is you will try to learn the in the YouTube and you will try to implement that, right? So when you are implementing, you will face a issue. That's the classic problem now we are going to discuss. So YouTuber will run something and get an output. So the same code space, you will try to implement in your laptop and you will not get the result. You will feel like, why is that? So the reason is the YouTuber will use different OS and different dependency versions. Those all are different. So that's how you will not get the same result. So there is a comic meme there. It works on my machine. Even think like there is a situation like if we are building in your laptop somewhere, and when giving that code, the same code to your friend, maybe not working in his or her laptop. So that's the issue here. It's work on my lab, my machine. Then what he is saying, we will ship the ship your machine. So that's how the Docker works. So I hope now you've got some idea. Rather than this instance, I may tell you another scenario, another anomaly apart from the tech. So now, if you think of an instance, you will feel like you would have tasted tea somewhere else. That's you will feel like that's a good tea in a shop. Candy or wherever some other in shop, you will feel like it. When you are making a tea at home, that may taste differently because of the ingredients are different. So what they can do is you're going and asking them, and you're in a cup, you're containerizing the milk powder, sugar, tea powder, everything, and containerizing, getting back to home. And you're pouring the hot water into that. So from that you may get the same taste, like thing like all the coffee machines and tea, because the constant same containerized, same milk powder, same ingredient. That's how here. Now, Docker also say what we have to do it. Now, how Docker solve this issue is Docker solve this issue by packaging the application and all dependencies, libraries, all the things in a single isolated call container. So this is the image showcasing you container image registry. So you can you can imagine a how to say, imagine a how relationship between Docker image and container. When you when you type a Docker file, when you build that, you will get a Docker image. When you run that Docker image, you will get a container. That's how the relationship is. So here, container is the instance, image instance. And image is the, when you build a house, there will be a blueprint, right? Image is such kind of blueprint. So registry is storing many statical images. Image is kind of unmutable. So now we will go to the next slide, where we will discuss about how to write a basic Docker file. This is the most common instruction in the Docker file includes. So now we will go through each and every line and how it is. So you can get an idea how to write a Docker file simply. So first one is from. From image. It means from is a keyword. This sets the base image in your on your container. This line is the always first line of the Docker file. And the meaning of this one is what they have. Your container thing like your container extends this image, same as a class extending another class like that. So next line is work directory path. Path is defined there. So normally we have to define a path here. The purpose of this line is, second line is, set the working directory inside the container. It means all the commands, copy, run, etc. will execute inside the app. And next line is copy host path and image path. What does it mean by is copies the files from your laptop to container. Copies everything from your project folder. And the fourth one is run command. Run command in the sense it's running a command during the during image build process. Meaning that commonly used for installing dependencies, compiling codes, those kind of things. And next one is environmental setup. This is environmental variables sets the environmental variables inside the inside the container image. As a environmental variable useful for configure values, API URLs, and so on. And expose the port. Here, thing like this is the port you are defining in which you have to expose it. Maybe 3000 or something. You can define that. And finally, the command, CMD command. This is the last one, and this is the practice we do. This is used to define the default command to run when the container starts. So this is the starting point. So this someone runs the only one CMD allowed per Docker file. That's how the this is the uh, common way of writing Docker file. This is the format. Now we will try to implement. Before implementation, I showed you to get an idea so you can understand that. Now we will go to demonstration part. If you all are working with me, it's better. Mm. Hope you can see my screen. Now, in this application, there is a front end, back end, and a database. So what I'm going to do is, I'm going to separately Dockerize back end separately, front end separately, and uh, database, and all these three I'm going to put in a container. It means like I'm going to have a Docker compose. So we will first of all see before this is the front end. This is the front end Docker file. Before going into this, you can remember, as I told, from is the first one, and we are copying here, making a directory and copying, so on it goes. Now I think you can remember the previous slide we have discussed, command file. So it is specifically now written for this front end. So again, I'm remembering you the concept. What is Docker image? That's a read-only blueprint that contains all codes and dependencies configurations and contain a running instance of a image. And Docker file, a simple text file containing instruction to build the image. Now, when we build this Docker file, we will get the Docker image. So now we will discuss the line by line. Okay. Okay. Now here from I have earlier told you this is the keyword. From keyword we have users node 20 slip image for building front end. So this one as I earlier told you, this is the initial from getting as in a built environment. This is the initial command that we always use. If it is a Python one, you will go with the Python one. And this is here, this is considered as a base image. You can even say base image. And here the second one is, as I told you earlier, second one is copying. We are making the file, storing working directory. So if you are not defining this working directly, it will automatically create a one. So here we are setting a working directory inside a container. So next this one. Here we are copying the package JSON. And next one, here, now here in this step, what we are doing is from this step, installing the dependencies. So after that, here you can I think I hope you can understand why we are all doing this one. When you are giving this code to your friend and if you want to make that as runnable, you have to install all the dependencies packages that you have used here. That's how now we are going to containerize everything. Now we are putting this one into our container. And what we are doing everything after doing that, here copies everything, copying applications code. And here uh, up to this, I have to introduce one theory. Then only you can understand the rest of the things. Here there is a concept, multi-stage build. This is one stage and this is another stage. The above part is one stage and below part is another stage. What does it mean by is stage one? Stage one, why we are using here, you can even do that in a single stage. Why I'm here using multi-stages, users stage one uses heavy image with compilers and build tools, SDK, NPM, those things. And stage two uses lightweight images. So where if it is much smaller size, final image will be smaller size. If you are using one stage only, the final image will be not smaller. And this is another advantage is faster for deployment and pulling. So here, this is stage two. Now we are going to discuss. Take some time, better you understand the stage one, I guess. Up to this one, stage one, and this is stage one, and below one is stage two. So if you have any doubts, you can ask. Here in the build thing, again, what we are doing is we are now we are getting a simpler version and we are running npm. And what we are doing here is we are exposing port also. Uh, but why we are getting this distill file is this is the output file we are copying finally in a stage 2, and this is exposing port. This is the port, front end port we are going to expose 3000. This is the port we have defined. When we containerize, this is the port it will run. So here environmental variables are set up, and here command file. This also finally this output listify the only we are getting here. So that's how the front end. And now we will discuss the backend Docker file. Uh, Hope you guys got that. How front-end Docker file is written. And now we will discuss about the backend one. Backend also same pattern. Uh, I think this one you can somewhat understand rather than before one, because the same pattern. Here again, how we start is from using a from keyword. Here we uses the .NET official .NET 8 .NET 8 SDK image containing build tools. So again, here what we are doing is sets the working directory to app/app image containing app used what we are doing app we are making a working directory /app inside the container. Here what we are doing is copying everything to container. So this is the pattern. Understand the pattern, guys. This is the pattern we are following. And again, here in this one, we are restoring distinct layers. It means look at packages, hashtag separately. It means look at packages. And this one, run.net publish. This one, what we are doing is we are only building and publishing. We are not building and publishing everything in the application. We are only building and publishing application app/out. That one only. So this is here also I'm using, this is the stage 1 and this is the stage 2. This is build time and the build 1, and this is build runtime image. So now we will go to second stage. This is the second stage. So here, what we are doing is, here we are only copying the DB and output file only. What we are doing is copies the database file from the build stage here in this code, and here we are copying the published output into the runtime container. Only both of the image, because for the backend we need database. We are copying the database one, and here we are publishing the this one. We run here, and that one we are copying here. Finally, DLL file as a .NET. If it is .NET, it's a DLL file, and if it is a Java file. That file here we are. This is the endpoint. runs the API when the container starts, this one. So now what we will do is, if you want to, this is the Docker file. Docker file uh, we have done. And if you want to run that separately, you can run. I will separately run the backend now, backend Docker file. See how it goes. Then when you are building that, what's the that's command, you have to remember those things. The command you use is docker build. So now you could able to see this is called Docker desktop. If you want, you can install you can install this in your Windows or in your OS. You can install this, and here the container images, those kind of builds you can view. Now what I have done is, here I have built the backend one just now. Here it is showing the status. I have built the backend to do API. So now I have built that. So what you after the building this one, you will get the image. So now what we have to do is we have to run that. After building, now we are going to run that. So now I have run that. So first what I have done is, first I built that. Now I have run that. Now we could able to see in the Docker image. Now as soon as I run and I refresh this one, we could able to see that one. Here it is showing backend to do API. So it is now with a green mark. Once you run that, it will show with green mark. Now container, right? So this is how you can able to see in the Docker desktop. And also you can run, remember these commands guys, docker ps, by running that one, you can able to see here, this is the container ID and this is now just a minute ago, wait, this is the container ID. When you are, uh, when you are that Docker compose down, you have to mention this ID also. And now, what I have done now, up to now is I have done for the backend. But this is not a, this is much taking time now when I'm doing for running backend separately and again front end separately. Now what I'm going to show you is here Docker Compose. Docker Compose, what we have done here is, rather than running every front end back end separately, here all the front end back end database, all we can all together we can build and run. So that one now we are going to do that one in a compose, Docker compose file. What I have done is front end, back end, all the things are defined here. Now we will see this one. Here, what you have to do is mm, services and networks volumes. You have to make it in the same alignment. And within services, backend and front end database, all these three should be in the same indentation. If you miss this indentation, it will make you error. Now you can see, right? Here error. So it should be in the same indentation. So this is first line and you can see the lines, right? Here backend another line, and within the backend image build, those kind of details are there. So So you may think like why we need this Docker Compose. So application usually consists of multiple components, front end, back end, database. Running each using separate Docker commands is messy, right? So for that only we are using this Docker Compose. So now we will look into these codes. So within backend, there is image. So this is the image we have built separately. You can see here in the backend, I have told you, in the backend, I have told you this is the image we have built. And here context, the where it is the relevant place of that in that packet. And this is the Docker file. Docker file, here we have mentioned like Docker file. And this is the port of that backend. Now I have typed and run 5053. And this is the host one. And this is the port resembles the container one. And here, this is the exposing port. And here, the network we have defined like to do network. Here also, previously I told you all should be in the same line: service, network, and volumes. Volumes I will discuss with you once we go to database, and network we are defining here. You all know when we are connecting everything, we need to have a network there. So this is the network we have defined to do network bridge one. And here we have mentioned that network to do app network. So simply environmental variables also I have explained earlier. Here connection string is a dynamic one. So dynamic ones are, we are putting here connection strings, API, those kind of things we can configure. Here depends on. Depends on means this backend file, usually backend depends on database. So when we put depends on, it will go straight away here. So this one will be run before that one. So we will see this one. The image when you see here, this one is backend to do app, and here also backend front end. Here, this is Postgres. What we have done is this is we got from the Docker Hub. So that's why here image is defined like this. And here variables related to Postgres, password and those things. DB is named as to do DB, and those things are defined. And here port, the same pattern guys, image, environment, ports, and why we are using volume here. So I need to explain you that one. Uh, the reason for using volume here is the data set will be loaded there. That's there in the volume. So already you have loaded data. So when you are typing Docker Compose down, when you type Docker Compose down dash v, it will clear the database volume also. So health check now you don't need to do that one. So we will go through the, so that's how overall front end, back end, front end database are written here. Same pattern here also in the front end. Image is defined, this that is to do front end, and here Docker context relative directory, and here Docker file, name of the file, and here environment and related environment, and port of ports are defined front end ports, and here network is to do network. And now what we will do is we will run the Docker compose file.
Samyukta,
Yeah.
there's a space before dash B. That's dash and D.
Give me a second.
No, not that. The one you ran. Docker run.
Chandala, is everything right?
There's a space between dash and D. Docker compose of dash D. That's it.
Ah, sorry. Yeah. Yeah, that's why I didn't notice that. Chandala, you can carry out and I'll fix this. I think it's running, but there's a issue. Chandala?
Yes.
Yeah, Chandala, you can continue the session. After this done, I will share and show you.
Okay. Uh, we'll move on to our presentation. Samita, there's another slide for you.
So, guys, these are the key benefits of Docker, which is portable and lightweight, also consistent. As I told you, this is portable, portable in the sense light, not this. Portable in the sense Docker runs exactly same the way on the laptop. So you don't need to install anything or it means no any ex extra memory or something. So it's portable and it's also container shares the host kernel. That's the key point of lightweight and consistent. Guarantees the guarantees that the dev test and those are identical, solving that issue that I mentioned, classical issue that I mentioned earlier. It's working on my mission. So now Chandra can discuss and later I will, once it built, I will show you the output.
Next, we have another question in our quiz. Let's move on to that. Yeah. So come on, guys. We had come halfway through our quiz. More than half. Quickly join. Mm. Okay, I'll start the quiz. What is the classic frustrating developer problem that Docker solved? Okay, that one all got correct. Well done. It works on my machine. So let's see the leaderboard. Yeah. Jayavardhana is on the lead, and there's another J, and Kumar, then Jayasurya. Mhm. Yeah. Let's see who will win the quiz after all the questions. Okay, we'll move on to our slides again. So before that, I need to show you something I could not show it earlier. So you saw that how I ran the Jenkins pipeline. So you may be wondering how to set up this Jenkins. You just have to Google uh, install Jenkins. Then you will have this link. Here you can install for Linux, Windows, anything. I have installed this in a Linux system in EC2. So in here you have all the codes you need to run in order to install Jenkins in your system. Here I have installed this long-term support release. I have run these codes, and then we can start Jenkins. So before that you have to install Java, because Jenkins uh, relies on Java. We need Java first. After Java you can install these things. And then this is to enable Jenkins. That means whenever your system starts, that will automatically start. And then you can start the service and check the status with this. Next in Jenkins, when you start it in the first time, you will have to unlock it. So you have to browse to not localhost. In here, I have, if you put this in localhost, you will have to go to localhost. In my case, I have put it into an EC2. So this is the EC2 public IP, and then 8080. Uh, Here you will get this screen. To find the password, you have to go to this location. You can go to this location from your terminal in the machine, and then you'll get the password. You can cat this, then you will get the password. Type this password here, and then click continue, and you can set up Jenkins. That's the video for setting up Jenkins. And Docker commands, you need to set up Docker. For that also, just Google how to install Docker. Then you have this Docker docs. Here you have Ubuntu Debian for every OS. Here you just have to run these commands they have given here. Then Docker will be installed in your system. You can test it from this command. So that's how you set up those things. And if you don't know how to create pipelines in Jenkins, same, you can Google Jenkins pipeline, and you will be directed to this site. Here they have indicated all the syntax and getting started using a Jenkins file. You can just follow this like a tutorial, and you can understand what are the things in a pipeline and how to use this. And that's the Jenkins pipeline. You also have GitLab action, GitLab CI, and GitHub Actions. In GitHub Actions, it is similar to Jenkins, but a bit different. Here, when you go to Actions, you can use a template, or either you can set up a workflow yourself in this one. Just like I have created that Jenkins file, you can type your code here, type your pipeline code here, then it will run that pipeline. This will be run from inside GitHub. They will be using a smaller machine for that. So if your pipeline is much bigger, it will take much time. and they also have a credit limit for that machine, like a time limit. But in Jenkins and we machine, so there's no such time limit to anything. That's the difference between these two. So you can even host this GitHub agent as a easy to even if you want a much powerful machine. So that's all about pipelines. Let's move on to the next one. So here, infrastructure as code. So what is infrastructure as code? Here, now we all know we need the environment, the dev, staging, production to test our uh, application and to host our application. So how do we create this environment? We can't just manually create all these environment, and there are VPCs and that means we have to create network zones to host those. If if I talk about EC2s, there's VPCs, virtual private cloud, uh, like that. We have to s- set up all those infrastructure whenever we are running in this environment. So we can't do that manually. We have automated that. That automation is called as infrastructure as code. Imagine you have to set up a new server, then uh, what you do is you will create this code, infrastructure as code in today I'll demonstrate Terraform. As a code, you can define what you need. Like if you need two EC2s of this uh, s- this kind of storage, this kind of type, then you can define it in your code, and then when you run that code, your infrastructure will be automatically deployed. So it is like a builder. Like there are two tools I'm talking about today, Terraform and Ansible. When we talk about those two, you can just for the sake of understanding, you can think that they are like the builder and the decorator. Terraform is like a builder. So what Terraform does it creates the house you want, and what Ansible does is it goes inside the house and decorates the house. It will put on curtains and stuff, and it will paint the house. Those things are done by Ansible. Terraform is the one who will build the house. So like that, Terraform can handle provisioning and managing cloud infrastructure in AWS, Google Cloud, GCP, and sorry, Azure. All those cloud providers are supported by Terraform. Uh, and then why do we need to create this infrastructure as code? We can for if that's a small project, we can just go through the console, AWS console, and create those infrastructure. But the issue is then that is not reliable. You have to build this infrastructure right every time. Like if you want to destroy it and rebuild it, you will have to rebuild it as uh, you had done previously. You have to remember all the steps. That is actually difficult. So that's why we are using infrastructure as code. Here we can create the environment 100% identical to the previous environment. So I'll do a quick demonstration on that. Mm, mm, mm. So in here I have another code called infra. There are Uh, mm, There are folders, as you can see, Ansible, Terraform, Docs, like that. We have to have a folder structure. This is the best practices method to create this infrastructure. Otherwise, we can just create files here and there. Then we will be unable to find what is where. That's why we are having this nice folder structure. We can create it. So for Ansible codes, I have one folder, and Terraform I have one. For Ansible, let's see, in here we have variables, and you have inventory files. In Ansible, you have file called inventory. Mm, I can't go through all of these in this short time. You can learn them from tutorials. There are templates. And this is the Ansible playbook. This playbook is like the previous Docker file, like that. This is also in YAML format. You have these indentations, and in this playbook, we have defined what we need in our infrastructure. Just assume it's easy to. So if that's an easy to, that's our server. So that's a fresh easy to. Only Ubuntu is there, nothing else. So we need these things to be installed in there to deploy our application. So that is done by Ansible. In here, these are the tasks that are given to Ansible. Update the cache. That means sudo apt update, like that. We don't directly put the codes. For some codes, like for command codes, you have Ansible codes we can use directly. Like for this one, we can directly put uh, sudo apt update, like that. That's code. Without using like that, we have Ansible defined way to run that update. So this is that way. So then when we run that way, we have much more control over how that code is being run. And we have to install these packages. So we just define the packages. We need curl, we need git, build essentials, engines. When we define this, it will install those things. And then download and install Node.js. This this is just a code, like that. What I told earlier. This is a normal code. It's a shell command. So this one, we don't need to type the entire code like this. For some, not for all. For this one, I have typed the entire code. Mm, like that, we can verify the installation, and then display the node version as a message. It will display in the shell, and create the user. Here, creating user. All these can be done by Linux commands now. So there are specific commands given by Ansible to make those tasks easy. So these are all like that, what we need for our application. Okay. And then show this. This is the directory structure for Ansible. Mm, So to deploy this, we can run an Ansible playbook -i. We give the inventory file and then the playbook, what to run. Like that, these environments are not created here. That actually we need to have those environment, but I have not created them here. If we had those environments, this is the way. Inventory dev uh, hosts. Here I have only one host file. For all the in those environment, I should have separate host files, and we can verify the deployment. Okay, and this is we'll move on to Terraform. In Terraform, the code is much better than that one. In Terraform, I have the environments, dev, production, staging. In all those environments, as you can see, there's main output, Terraform TF was example, and variables.tf. I'll first discuss about dev. So in dev, we have main.tf. This is the main file in Terraform. Here we have the required version of Terraform, then the service providers we need. And I'll tell about this later. And we define the provider, and the modules, what we need. Networking, module networking. Networking means we in Terraform we have divided these things into modules. That's the best practice. And these modules are separated into folders. As you can see, these modules are coming from here. This is the module. In here, I have compute. In compute one, I have this uh, information related to the EC2. Here, what is the AMI I need, and what is the key pair I need for that EC2, and what is the IAM role for that EC2, like that. That is related to compute. If I go again to the main, here there should be a one called compute. This is the compute module. So I have called this compute module from that compute main inside this compute folder. From that I have taken this. I have called here just the variables. I have set the variables. So this is like a template. All are set as variables. Here var dot name prefix var is the variable. Those variables are defined in variables.tf. These are the variables in this module. So we can use these as variable. There's a default value. If you want, you can put that and the type like that. These variables will be set by the root main function. This one. This That's how we modularize this infrastructure creation. So this is a very big code, even though that a small infrastructure we are creating. That had become bigger because of that best practices we need. Oh, okay. Like that in networking we have related to VPC, internet gateway, subnets, all those data are in here. And security we have load balancer security groups mainly. Those are here. So each of them has the variables.tf where variables in that module are defined, and the output.tf defines what are the outputs that it will produce when this module is getting created. So those outputs can be on the root main function, and they can be used for our other users as well. So in here, uh, next, that's the same story for production and staging as well. I'll show the best practices. Uh, you should have module architecture. That means you should have modules separated for each thing you are going to implement. And there are environment separation. And this is the remote state management that I told I'll tell back in. So in Terraform, if you had run a Terraform earlier, you may have seen that there's a Terraform.state file being created. That state file saves all the things that have been created by the Terraform code, so that when we run it again, it will check that state file with the, let's see, AWS. So with the AWS, it will check whether these things are already there. If they are somehow removed or something, then there's a mismatch. For that mismatch, it will recreate those infrastructure again. So that's the use of state file. But the issue is when we run this Terraform apply from our machine, that state file is only getting created in our machine. And also we don't put those state files normally in Git. So that we uh, have a Git ignore here. Here state files we normally ignore from the Git. So they don't go to our repository as well. So only we have it. When we are doing this in a team manner, if I run the Terraform apply and then another person of my team run the Terraform apply again, he doesn't have that Terraform state file. So he will create already created infrastructure as well. He will try to create them again. So if you know, like S3 buckets, they have a name which is global. That means you can't have two S3 buckets in the entire world with one name. So if I create one S3 bucket from my end, then then the other one who is uh, running Terraform apply will try to create another S3 bucket. So that will cause error in the code and it will fail. So to avoid those things, we are sending that state file to a remote backend, like another S3 bucket. For example, we can put it into S3 bucket. Here I have defined the bucket name, DevOps workshop Terraform state. This one I have to create manually. This one I have to have before I run this Terraform apply. So I have created this one earlier. Then when I have defined this like backend S3, uh, here the state file will be saved in this S3 bucket as a dev/state file. Then whenever another person in my team runs the same Terraform apply, it will check for this backend S3. So there we have the S3, we have the state file available for all the users. So the already created infrastructure will not be created again, and we can resolve those issues that happen within the team. There's also a DynamoDB table we use that is used for the Terraform state lock. This state lock is used when I am running Terraform apply from my end. It is still creating the resources. Then from another person's laptop, if he runs the Terraform apply again from his one, then we both have access to the same state file. But even then, the state file is not yet updated because I am currently creating the resources. To avoid running another apply when I am creating the resources, I will place a lock in this DynamoDB table. There's for one row, I will say I am locking this row. Then it will first check this row in this table. If that is locked, then it will not run the Terraform apply. It will run only when it is unlocked. So when I finish my Terraform apply, only it will get unlocked. That is the way to avoid any race conditions that may happen during Terraform apply. So then we have variable management. We have used variables as much as possible so that we can directly use those. So this is also the variable defined in this main.tf and Terraform tf.was. This is an example. So like that, we can create one. We can create one and create our own resources. This one we do not commit. So I can have my own resources like that. Mm. Okay. Mm. Then we can add CloudWatch monitoring, those things. These are the codes related to Terraform. Terraform FMT means we can format the code like in Terraform there's a format now like this, just formatting, general formatting. Then we can validate any syntax. If there are any syntax errors we can find it here. Then we can scan as well. And then we normally use Terraform plan and then Terraform apply. If in Terraform plan, it says now these things will be created. Then when we put Terraform apply, it will create those. So that's all for that. Yeah. So that's the things related to Terraform. So this is the overview of the folder structure. In Terraform, there are modules. In modules, we have main.tf for that module, and these are called within the environment. Within the environment, this is the main root main function. Yeah. So that's the things related to Terraform. We'll move on to our presentation. Yeah, there's another quiz. We'll move to the quiz. Okay, can you guys join quickly? There are about 3 questions. Also, you can ask any question if you have regarding all the things we have covered earlier. Okay, 5 are ready. Come on. There's a question. Is it necessary to have certifications to apply and work in the DevOps or software engineering field? That's not a necessity, but it is better to have certifications for DevOps because there are certifications. Like uh, more than software engineering field, there are many certifications for DevOps because in DevOps we use hundreds of tools. So for most of those tools, there are certifications. For example, AWS, there are a wide range of certifications. And for Terraform, there's one. And Ansible also, I think there are some, even not official certifications, there are small certifications from LinkedIn, Coursera, Udemy, but uh, it is better to learn from those. Like those certifications don't give that much value, the Udemy and those things, but you will gain the knowledge from doing those things. what gives values are the certifications given by popular providers like AWS, Azure, GCP, and there's one from Terraform. Like that, if you can do those certification, then you will stand out from the crowd because there are many people coming to this software field now. As a software engineer, you can have certification like Java certified, and for DevOps Kubernetes side, there are many more certifications when we go to that side. In DevOps side, there are many certifications you can have paid. Most are paid. Most certifications are like 30,000, 50,000. You have to pay for those. If you are going to interns, then from that company, you can claim those. Some companies give, they are, they will provide you money, or they will provide you some kind of way to do that certification free. Mm.
Let me
Yeah.
share my screen to. Do you have list of the questions?
Wait, I have another one.
Okay. Okay.
Is it same with GitLab also? I think this is the Jenkins one, CI/CD. It is the same in GitLab. No, not the same actually. The code is a bit different. You have to identify that the Jenkins value, the Jenkins code, CI/CD code, and the GitLab, GitHub Actions code is a bit different, but it is manageable. Like uh, you can go with those things. GitLab is now much popular. It is becoming much popular than Jenkins for CI/CD. So you have to learn that too. It is better if you can learn that too. Yeah. Uh, Samyukta, shall we go? Okay, I'll
Yeah.
give you the
Shall I
screen.
share the screen?
Yeah, I'll give you the screen first.
Hope you guys can see the screen. I have showed you, I have discussed with you about Docker Compose file. So here, Docker Compose, I have used, we could able to you could able to see here containers, backend, front end, and uh, volume in the sense database things are there. And now we could able to see this by Docker PS. By typing Docker PS command, we could able to see this. These are running in the containerized here. Docker front end, back end, all of them are running here. Now you can view the view in the Docker desktop also. Here Postgres backend database is there, and backend to do API to do backend and to do front end also work. Here these are the images and containers. These also you can see here. Here these are there. And builds also you can watch. These are the images. Builds and these are the images and volumes you can watch, and also container you can watch. And here, as I mentioned you, I exposed the post earlier. You have to see the front end in which post we exposed. Here we exposed that in a 3000, port number 3000. Here localhost 3000. Here front end is simple front end is there. This is the containers. And now what we are going to do is without stopping them, stopping the container, in the background resource will be running up. So what we have to do is we have to type the docker compose down command. So we will do that and I will show you that. So when you are typing this command, all will be removed. All the results will get released. And when you are typing again docker ps, so now you couldn't see any of them. Previously, when you are when it was running, you could able to see all the here container ID and one ID for the front end and back end. All the things you could able to see here. Now you couldn't able to see anything. So that's how you have to stop that. So hope you got that. And within one day, it's hard to get that. You have to practice that. You all having DevOps module also practice that. Get an idea. Chandula.
Okay, we'll move on to the quiz again. We completed. Yeah, can you guys come for the quiz? Four are there. The time is running out. Okay, I'll start the quiz. What is the core principle of infrastructure as code? Yeah, all are correct. Next one. What is the primary role of Terraform? And that was all but correct. The next one. Mhm. What are the two main benefits of this automated process? That also all are correct. Okay, next we move on to the slide. We have the last part. I think monitoring. So now our code is in production. Now our code is live. The entire world can see our application and they are working with it. Now you may think we are done. Now DevOps job is over. No, the DevOps job is not over even then. The software engineer, the developers, they can go home and rest, but DevOps guys had to stay and see whether this application is working correctly continuously. Now we have to watch it. Now this watching part is called the ops. We have dev and ops. Dev means the development side. The ops is the operations side. In here, monitoring is one of those operations. We have to say whether the application is working and is it slow, is it crashing. We have to look into that. There are three main ways in this monitoring: logging, metrics, and alerting. Logging means this is the black box recorder for app. It is like in an airplane, you have the black box. In here, it records every single event and error that will happen in your application. If something breaks, if the logs are the first place you have to look into. Then we have the metrics. This is the dashboard or Fitbit for your app. In the Fitbit uh, watch, you can see that your heart rate and what steps had you taken, like that. In metrics, we can see how much CPU is it using, how much users are logged in, and how much memory is free in the server. Those things are seen in this metrics. This is like a dashboard. Then we have the alerting part. This is the alarm. Why do we have alarm here? Because we as humans, we can't be staring at a dashboard 24/7. So what we do is we set up rules. If metrics go bad, like the site is down or the CPU usage is at 100% for 5 minutes, like that, it automatically sends a notification from Slack, from email. However, it will notify the team to look into the error. And you will use a ton of amazing tools like this, like Prometheus, Grafana, Amazon CloudWatch to work with these. Like I have generally put these tools based on the most general thing done by that tool. Most of these tools have all three. Like for CloudWatch, you have the logging part, metrics part, alerting part, all. And OpenSearch is mainly for logging. Prometheus also like that. You can have dashboards, different kind of dashboards in Datadog. Datadog is not a free one. It has, but it has many extensive dashboards. You can look into your application. So that's for monitoring. And last, what I have to say is, DevOps is not a role. It's a culture of collaboration between development and operations to deliver value faster. Earlier also, software engineers were there, applications were built, but it was slow. The application development was slow and it had bottlenecks. That's why DevOps came to make this software develop faster and reliable. So, DevOps is the wall. Uh, we have to break the wall between the developers and the operation team. So as a DevOps engineer, you will have to work with all the teams in the company, like the QA team, the dev team, the tools teams, uh, and the infrastructure teams. You are working with entire uh, team set in that office. So the tools we use as DevOps are just there to help us build this culture of collaboration. And thank you. That's the end of the presentation. We'll move on to the last questions we have. Yeah. Can you guys join quickly? There are only two questions, and then we can see who has won today's quiz. Hmm. I'll wait for a few seconds. I think that's all. Okay, we'll start the quiz. In monitoring, which part is the alarm that notifies the team when the site is down? All are correct. That's highlighting. Then the final question. Collaboration between development and we somehow one hand only answered. Okay. We'll go to the leaderboard. Jayavardhana is there. Yeah, Jayavardhana is the fastest. Who is Jayavardhana? Can you show your hand or can you if you can show your face, that's better. Turn on your camera. Are you there? Uh, Somehow he's the first. Second is Jayasuriya. And congratulations. I think we use this quiz to make it more engaging because it will be boring to listen to this like a lecture. That's it. Okay, then. Thank you. That's the end of our session. Over to you, moderator.
Thank you very much, Mr. Chandula Jayatilaka and Ms. Samyukta Vimalanathan for that insightful and very much engaging session. And I guess that brings us to the end of today's amazing session. And on behalf of the IEEE WIE Affinity Group, University of Ruhuna, I'd like to express our heartfelt gratitude to Mr. Chandula Jayatilaka and Ms. Samyukta Vimalanathan for sharing knowledge and your insights on version control, containerization, and modern deployment workflows have given all of us a much deep understand software projects. This token of appreciation, your contribution so far to Wisdom Waves 1.0. And with that, we conclude today's session on the journey from code to production. A big thank you once again to our speakers and to all the participants who joined with us today. So stay tuned for more exciting sessions ahead. And until then, keep learning, keep coding, keep riding the wave of innovation. Have a good night.